All right, so you're gearing up for the AWS Developer Associate exam, and you know those ElastiCache questions can be tricky. Well, today, we're going to demystify all of it. We'll break down the exact patterns and logic you need to absolutely nail those questions. Let's do this. You ever hit one of those practice questions and just freeze? You're trying to figure out which caching strategy to use, or maybe you're stuck between Redis and Memcached. Don't worry, you are not alone. And in the next few minutes, we're going to flip that confusion into pure confidence. So here's the game plan. We're going to start with the absolute core caching patterns you'll see on the exam. Then we'll get into how to keep your data from going stale using something called TTL. After that, we'll tackle the big one, Redis versus Memcached. And we'll wrap it all up with some pro-level tips on performance and security. Let's jump right in. First things first, let's talk about the two fundamental caching patterns that are, honestly, the bread and butter of ElastiCache. If you can get these down cold, you are already way ahead of the curve. Okay, this is a classic. You will see a question like this, I guarantee it. This pattern, called lazy loading or cache aside, is probably the most common one out there. So let's walk through exactly what happens when the data isn't in the cache. The most important thing to remember here is that your application is the one driving the bus. It asks the cache for something, and the cache says, nope, don't have it. That's a cache miss. So what does the app do? It takes charge. It goes straight to the database, grabs the data, and then, this is the key part, it puts that data into the cache for next time. The big advantage? You only cache the data that's actually being requested. So lazy loading is awesome for reading data. But what about when you need to write or update data? This is where our second pattern, write through, comes into play. And it's all about making sure your cache and your database are always in sync. The exam loves to test you on this. And here it is, the secret sauce. With a write-through strategy, when your application writes new data, it doesn't just write to the database. It writes to the cache and the database at the exact same time, in a single operation. This means your cache is never, ever out of date. The small trade-off? Your writes are a tiny bit slower because you're writing to two places at once. But for data consistency, it's unbeatable. Okay, great. We've got data in our cache. But what happens when that data changes in the database? We can't just leave the old stuff in the cache forever. This next part is all about managing the lifecycle of your data to keep things fresh. This right here is so fundamental. Think about it. A cache that never gets cleaned out is basically a ticking time bomb. It's a memory leak just waiting to happen. The exam is absolutely going to expect you to know the name of the tool we use to stop this. And the answer is TTL, which stands for time to live. It's a super simple but incredibly powerful concept. You just put a timestamp on every piece of data you add to the cache. You're basically telling ElastiCache, hey, this data is only good for, say, 300 seconds. Once that time is up, poof, it's gone, automatically. This does two amazing things. It prevents you from serving old, stale data, and it keeps your cache from growing out of control. Now, TTL is fantastic, but it can introduce a really interesting problem. Imagine you have a super popular piece of data, like the homepage of a news site, and thousands of people are requesting it every second. What happens when its TTL expires? Bam! All of those thousands of requests suddenly miss the cache at the exact same moment and slam your database all at once. That's what we call a cache stampede or a thundering herd. So how do we fix this? The solution is really elegant, actually. It's called TTL jitter. Instead of giving every item the exact same TTL, like 60 seconds, you add a little bit of randomness. So one item might get a TTL of 58 seconds, the next gets 63, and another gets 61. By spreading out or jittering the expiration times, you prevent that massive simultaneous wave of requests from ever hitting your database. It's a simple trick that can save your bacon. Okay, we've got our patterns down, we know how to keep our data fresh. Now it's time for the big question, the one you'll see in so many exam scenarios. Which caching engine do you choose? ElastiCache gives you two main options, and knowing the difference is non-negotiable. This question gets right to the core of the issue. The choice between Redis and Memcached isn't just about raw speed, it's about the features you need. So when an exam question starts talking about specific data structures or things like backups and high availability, well, those are huge clues pointing you to the right answer. This table tells you everything you need to know. Look, if the exam scenario mentions anything beyond simple key value pairs, like we need a leaderboard, which uses sorted sets, or we need to store a list of recent items, your answer is Redis. Full stop. If it talks about needing multi-AZ with automatic failover or taking backups and snapshots for persistence, again, that's Redis. Memcached is your lean, mean, simple caching machine. It's super fast and multi-threaded, but it doesn't have all those fancy bells and whistles. All right, you've got the foundations locked in. Now let's level up and talk about some of the more advanced stuff, optimizing performance and locking down security. These are the details that separate a good score from a great one on the exam. Okay, so you see this in the logs, a low cache hit ratio. That is a huge red flag. It means your cache isn't doing its job. Most requests are missing the cache and going straight to the database, which is exactly what we're trying to avoid. The exam will definitely expect you to know how to troubleshoot this. So it's pretty simple when you think about it. There's a direct connection between TTL and your hit ratio. If your TTL is too short, popular items get kicked out of the cache too quickly. By increasing the TTL, you keep that frequently accessed data around for longer. And the longer it's in the cache, the higher the chance the next request will be a hit. More hits mean fewer database queries, and that means a faster, happier application. Now, don't forget, caching isn't just about protecting your database. A lot of exam scenarios will involve optimizing other slow parts of your system, like caching the response from a third-party API that takes forever to respond. And this is where ElastiCache is so incredibly flexible. At its heart, it's just a key value store. You can put anything in there. It can be database query results, a fully rendered piece of HTML, or, in this case, the JSON response from a slow API. By caching that API response for a few minutes, you can save yourself from making that slow, expensive, and maybe even costly network call over and over again. This is a super practical, real-world question. You're about to deploy some new code, but what about all the old data sitting in your cache? If you don't get rid of it, your users might see weird bugs or inconsistent information. So how do you safely clear things out? You've actually got a few tools in your toolbox for this. The simplest way? Before you deploy, just lower the TTL on your data so it expires really quickly on its own. Or you can be more surgical and have your code explicitly delete the specific keys you know have changed. For a total scorched earth approach, you can even just create a brand new Redis cluster to start completely fresh. Last, but certainly not least, security. This is a massive topic on AWS exams, and ElastiCache is no exception. You absolutely must know how to lock down your cache and make sure only your application can access it. The best way to think about this is like layers of security for a castle. Your first line of defense is the network. That's your VPC and security groups. This is the moat and the drawbridge, controlling what can even get close to your cache. Then, to actually get in, you can use Redis Auth, which is basically a password. And finally, for controlling who can manage the cache itself, like creating or deleting it, that's where you use standard IAM policies. That's like controlling who has the keys to the entire kingdom. And there you have it, the core strategies, the patterns, the big engine decisions, and the pro tips for ElastiCache. You are now way more prepared to tackle those DVA CO2 exam questions with confidence. So the only question I have for you is, what's the first slow part of your own application that you're going to speed up with a cache?